Today we're going to be working on Chapter 6. This is our first section, and it's really not in the book. This is an Algebra 1 review. So we're going to look at the 7 different laws of exponents, or different rules of exponents. So you can preview this as product of powers, quotient of powers, zero exponent, power to a power, or power of a power, product of a power, power of a quotient, and negative exponent. Those are the 7 different laws or rules that we're going to follow here today. But we're going to start off easy. We're going to do product of powers. So anytime we multiply the same bases, we're just going to add the exponents. So these two are multiplying. We're just going to add our exponents. X squared times x to the fourth is x to the sixth. In this case, for the next example, we have x squared, y to the third, and x to the first. So I like to rewrite this as x squared times x to the first times y to the third. Since the x's are the same base, we can add the powers, so I end up with x cubed. The y to the third, or y cubed, doesn't get to change, and it doesn't get to add on to the powers of the x's because they're different bases. They're not the same family. Quotient of powers is when dividing the same bases, we subtract the exponents, and we look from the top down. So in this case, we have a rewrite of y to the sixth minus the third, because we're comparing these two, and so we end up with y to the third. An easy way to recognize this is we have 1, 2, 3, 4, 5, 6 y's on top, and we have 3 y's on the bottom. We can cancel out 3 on top and bottom, and we're left with 3 on top. Same principle here. We can talk about that with z's. We have 2 z's on top, and we have 1, 2, 3, 4, 5, 6, 7. We can get rid of 2 on top and on bottom, and we'll be left with 1 over z to the fifth. Now, again, I'm going to look at this differently, and I'm going to say this is really z to the second minus 7, which is going to get you z to the negative fifth. Well, we're going to talk about negative exponents towards the bottom, but anytime we have a negative exponent, it's really going to tell you that it's in the wrong location. This one shouldn't be in the numerator, it should be in the denominator, vice versa. You can think about it as reciprocals as well. This is my favorite one, the zero exponent law. This is anything raised to the 0 power, or any base with the exponent of 0 is the number 1. So 5 to the 0 power is 1. 912 to the 0 power is 1. X squared times y to the 0 power, well, this is really x squared times 1, which is going to get you just x squared. So essentially you can cross them out and just say, hey, this is 1. All right. Feel free to pause at any time. Go back to the video and review. This time we're going to raise a power to another power. And so the rule is a power raised to another power will result in multiplying said powers. So this is now 5 raised to the 2 times third, which is going to get 5 to the sixth. And if you really want to see this, this can be built as repeated multiplication, so 5 squared times 5 squared times 5 squared. And we already know if you multiply the same bases, it's the same as adding them, and you should end up with 5 to the sixth. X to the third raised to the seventh, well, that's just going to result in 3 times 7, x to the 21st. Done. Now, we're going to start getting into trickier and trickier rules. Power of a product is the power of 2 or more bases raised to the same power will share the power. This means we're going to distribute the power. Now, one place where this does not work is when we are trying to distribute the power over a sum or difference. So I'll say on this one, x plus y squared, you cannot distribute the power over addition or subtraction. We have to always rewrite addition and subtraction problems out as x plus y times x plus y. And then you're going to use distributive property or FOIL or the generic rectangle, any method that you choose. So this only works with multiplication. And you can see with our first one, this is x times y raised to the second power. So this is really x to the first times y to the first raised to the second power. So we're really just going to be multiplying the powers. So x to the first raised to the second is x to the second times y to the second. Let's try it with the next one. I'm going to rewrite this as 6 times x squared times y, and I am going to break them up because they're all different bases. Numbers are their own bases, x's are their own bases, and y's are their own bases. This is 6 to the first and y to the first. And all three of these things are being raised to the third. So I am now going to have 6 to the first raised to the third, x squared raised to the third, and y raised to the third. And so what I get here is 6 to the first times the third times x squared, x raised to the second times 3 times y to the first times 3. There it is. And so we're just raising the powers to another power, and we get a final product of 6 cubed times x to the 6th times y to the 3rd. And we can go one step further. 6 times 6 times 6 should be 216 x to the 6th, y to the 3rd. So this would be the most simplified form. And that's kind of what we expect to see. So again, pause, rewind, watch that one again. Remember, we have 3 different bases here. We have numbers, x's, and y's. So again, pause, need to go back, watch it a few times. Same thing happens with quotients, which means division. A quotient of 2 or more bases raised to the same power will share the same power. This means it's distributed. This does not work for sums or differences like we talked about before. It only works for multiplication and division. So in this case, this is x to the first, y to the first, and they're both going to have the second power now. So this is x squared over y squared. And if you want to see this in a different form, since this is xy times another xy, well, you have 2 x's on top and 2 y's on the bottom, and you get the same result. We're going to apply the same principle here. We have 6 to the first power over x to the second power times y to the first power. And this is all being raised to the third power. Each one of these different bases will get the third power. So this should be 6 to the third over x to the 6th times y to the 3rd. And we'll get a final simplified version of 216 x to the 6th, y to the 3rd. Our last law of exponents, or rules of exponents, is any base raised to a negative power indicates the base is in the wrong location, aka reciprocal. So I like to think about it as wrong place, wrong time kind of thing, wrong location. So I have x to the negative 3rd power on or in the denominator. It's stating right now that it shouldn't be in the denominator, it should be in the numerator. And once it crosses this boundary, going from the denominator to the numerator, it's going to lose its negativity, so it's going to lose its negative power, and it's going to change it to x to the 3rd over 1. So now it's in the right location, it's positive, and it's on top. So if you want to simplify this further, you can just say this is x cubed. The second problem's a little trickier because we should rewrite it as 2 times x to the negative 4th. The 2 and the x are their own bases. And this is an important fact that we have to realize. The x has its own power and the 2 has its own power. The 2 has a power of 1. So it's not moving anywhere. It's going to stay on top. But the x has a negative power, so that means it needs to go from the numerator to the denominator. And so now it's going to be 2 over x to the 4th. And this is our final simplified version. So if you have any more questions, please feel free to reach out to any one of us in the department. And I hope you guys have a wonderful day. Again, feel free to review this video and make sure that you watch it a few times if you get lost. Thanks again.